Okay. Now, what is angle of asymptote? Angle of asymptotes are the root locus branches which are approaches to infinity. Okay. Now, first you just carefully observe the definition. Angle of asymptote theta A. Angle of asymptotes are the root locus branches which are approaches to infinity. Now the question is why it is approaches to infinity. Now we are searching for 0, right? We are searching for 0. Now generally the root locus diagram ends at k equal to infinity and ends with open loop 0. So this angle of asymptote, the angle of asymptote is the direction which is showing that where the root locus branch is terminating. Okay, the angle of asymptotes are the root locus branches which are approaches to infinity. For easy language I am saying, if the angle of asymptote is 30 degrees, means if you go in 30 degrees direction, definitely you will meet 0. Understand? If the angle of asymptote is 45 degrees, so if you go in 45 degrees direction, you will meet 0 because you are already started at pole and you will go and meet 0, then the root locus diagram is called as a complete root locus branch, right? Now what is the angle of asymptote? Now the angle of asymptote is nothing but 2q plus 1. The angle of asymptote formula is the angle of asymptote which is equal to 2q plus 1 into 180 degrees by np minus nz. This is the angle of asymptote theta A. 2q plus 1 into 180 degrees by np minus nz. These are the angle of asymptote. Now, where q is ranging from 0, 1, 2 and so on, np minus nz, np minus nz minus 1. np minus nz minus 1. Now this is the angle of asymptote which is equal to 2q plus 1 into 180 degrees by np minus nz, q equal to 0, 1, 2, 3 and so on, np minus nz minus 1. Now let us check, we'll take one small problem. And the first problem, now this is g of s which is equal to k by s into s plus 2 into s plus 4, k by s into s plus 2 into s plus 4. Now total number of poles, np is the total number of poles. How many are the total number of poles? The total number of poles are 3, 1, 2, 3. Total number of zeros, what is the total number of zeros? There is no 0 here, nz is 0. What is np minus nz? np minus nz, 3 minus 0 which is equal to 3. Now what is the range of q? Q is 0, 1, np minus nz minus 1, which means 3 minus 1. 3 minus 1 is 2. Now what is 3 minus 1? 2. So q is 0, 1, 2, which means that, now see here, when q equal to 0, then what is the first angle of asymptote? The first angle of asymptote is 2 into 0 plus 1 into 180 degrees by np minus nz is 3. And second angle of asymptote, the second angle of asymptote theta A2, 2 into 1 plus 1 into 180 degrees by np minus nz is 3. And the third angle of asymptote 0, 1, 2. And the second angle of asymptote theta A3 which is equal to 2 into 2 plus 1 into 180 degrees by np minus nz. 2 into 2 into plus 1 into 180 degrees by np minus nz is 3. Now see here. Now the first angle of asymptote 180 by 3, 60 degrees. Now this is 3, 3 cancel. This is 180 degrees. Now this is 360 into 5. This is 300 degrees. These are the three angle of asymptotes. These are the three angle of asymptotes. Now the question is the angle of asymptotes. Now see, the angle of asymptotes are the root locus branches. The angle of asymptotes are the root locus branches which are approaches to infinity. Means 60 degrees direction. If you go 60 degrees direction, you will meet 0. If you go 180 degrees direction, you will meet 0. If you go 300 degrees direction, you will meet 0. Okay. Now these are the three angle of asymptotes. Total how many number of angle of asymptote? 1, 2, 3. Now see here. This is the first angle of asymptote, second angle of asymptote, third angle of asymptote. The total number of angle of asymptotes are the difference between poles and zeros. What is the difference between poles and zeros? The difference between poles and zeros is 3. So the total number of angle of asymptotes are the difference between poles and zeros. Now my question is, the difference between poles and zeros are 3. Therefore, there are 3 angle of asymptotes. If the difference between poles and zeros are 5, there are 5 angle of asymptotes. If the difference between poles and zeros are 10, there are 10 angle of asymptotes. Okay. Now these are the angle of asymptotes. Now you understand what is angle of asymptote? 60 degrees means if you go 60 degrees, you will meet 0. 180 degrees, if you go 180 degrees, you will meet 0. If you go 300 degrees, you will meet 0. Understand? No? These are the angle of asymptotes. Okay. And this is the formula for that. First you note down this. Okay. Now students, then I am giving one important point here. The total number of angle of asymptotes are the difference between poles and zeros. Okay. Now see here. Now the total number of angle of asymptotes are the difference between poles and zeros. Therefore, the difference between poles and zeros are 3. Therefore, there are 3 angle of asymptotes. Now my question is, whether 3 or 4 or 5 or 6, whatever it may be, but what is the first angle of asymptote? The first angle of asymptote formula is always, the first angle of asymptote formula is nothing but q equal to 0, right? Q equal to 0 is the first angle of asymptote. 180 degrees by np minus nz. Now 180 degrees by np minus nz is the first angle of asymptote formula for any problem. For every problem, the first angle of asymptote is 180 degrees by np minus nz. Now I am asking one question. Now for this particular problem, what is the first angle of asymptote? First angle of asymptote is 180 degrees. Don't see there. You just again find here. 180 degrees by np minus nz is 3, which is equal to 180 by 3, 60 degrees into 1, which is equal to 60 degrees. Then there is no need to remember any other formula. The second angle of asymptote, which is nothing but first angle of asymptote multiplied with the next odd number 3, which is equal to 180 degrees. And the third angle of asymptote, which is equal to same first angle of asymptote multiplied with the next odd number 5, which is equal to 300 degrees. Will get the same result or not? 60, 60, 180, 180, 300, 300. Now this is the shortcut method. Don't use the formulas and all these things. Only first angle of asymptote is nothing but 180 degrees by np minus nz. Now np minus nz is a difference between poles and zeros, and find the first one. Next, all remaining angle of asymptotes are the odd number of first angle of asymptote. But don't continue. You know how many are the total number of angle of asymptotes? 3, 1, 2, 3. Stop it. Okay. If it is 4, 1, 2, 3, 4, stop it. If it is 5, 1, 2, 3, 5, stop it. Understand or not? So the total number of angle of asymptotes are 3. These are the 3, and that is general procedure, and this is a shortcut procedure. Will give the same result or not? Yes. Now these are the angle of asymptotes in the shortest manner, and that is the general procedure. Okay. Now note down this one also. And one more thing also I want to say that now these are the angle of asymptotes. Okay, there are 3 angle of asymptotes, and angle of asymptotes are always symmetrical. Angle of asymptotes are always symmetrical. Angle of asymptotes are always symmetrical. Now check what is the first angle of asymptote? 60 degrees. This is 0 degrees. This is 90 degrees. Now exactly middle is 45 degrees, but this is 60 degrees. So greater than 45 and less than 90 degrees. Now this is the first angle of asymptote. Then students, I am saying, if you have one angle of asymptote, don't see the second angle of asymptote, draw the symmetrical angle. Angle of asymptotes are always symmetrical about the real axis. This is theta 1, which is nothing but 60 degrees. This is theta A1, which is nothing but 60 degrees. You immediately write the symmetrical angle. Don't see any angle is existing or not. This is a symmetrical angle. This is another angle of asymptote, which is nothing but minus 60 degrees. It is existing. Okay, you don't check, it is definitely existing. And another angle of asymptote. Now in a easy language I am saying 0 to 180 degrees. Now if any angle is existing between 0 to 180 degrees, take all the symmetrical angles. If it is 45 degrees, minus 45, minus 35 degrees, plus 35, plus 100 degrees, minus 100, 60, minus 60, 180, minus 180, like that. So all the angles you can again take the second angle. Now if one angle is existing, take the corresponding second angle, which is symmetrical angle for that. Now 180 degrees, this is the 180 degrees. Now this is 180 degrees, which means that, sir, minus 180 degrees, this is the same, minus 180 degrees and plus 180 degrees, both are same. That's what I am saying, angle of asymptotes are always symmetrical. And you have a doubt, sir, 60 is existing, sir. Okay, this is existing, sir. 180 is also existing, sir. But where is minus 360, sir? Minus 60 is not existing, sir. Only 300 is existing. So you just subtract the angle with, you just subtract that angle with 360 degrees, then you can get the angle. Okay. Now this is 300. Okay. This is the 300 minus 360 degrees. Right? 300 minus 360 degrees is nothing but minus 60 degrees. No, no, sir, I want to see that is 300 or not. 0, 90, 180. This is, what is this? This is 270. This is 360. Greater than 270 degrees and less than 360 degrees. Greater than 270 degrees, less than 360 degrees. Any angle, if it is greater than 270 degrees and less than 360 degrees, now that angle is nothing but 300 degrees, which is a minus 60 degrees, which is matching or not. That's what I am saying. You just do only one step blindly. Angle of asymptotes are always symmetrical. 40 minus 40, 30 minus 30, 180 minus 180, 60 minus 60, 135 minus 35. Okay, angle of asymptotes are always symmetrical. This is very, very, very important point. Okay. Now, angle of asymptotes are always symmetrical. Angle of asymptotes are always symmetrical with respect to real axis. Angle of asymptotes are always symmetrical with respect to real axis. because the poles and zeros are always symmetrical about the real axis. Okay, so this is the angle of asymptotes are always symmetrical. Now there is another question, where you start the angle of asymptote. Who says that you want to start here? And I can start here, I may start here, I may be started here. Now where I want to start the angle of asymptote? The intersection point of angle of asymptotes, the intersection point of angle of asymptotes is called as centroid. The intersection point of angle of asymptotes is called as centroid, represented by sigma. This is called as centroid. Sigma. The intersection point of angle of asymptotes on the real axis. Now that particular point is called as centroid. Now students, what we have to do it? No, you don't calculate angle of asymptote first. You calculate first centroid, and after that you want to do the angle of asymptote. Okay, for getting the understanding of that particular definition, first I am doing this. But next problems, you first find centroid and angle of asymptote, because after angle of asymptotion calculations completed, where you start, that starting point or that intersection point of angle of asymptotes is nothing but the centroid. Now we will see how to find the centroid. Okay, first you just verify this. Now you can understand. Now if you go in this particular direction, definitely will meet 0. If you go in this particular direction, you will meet 0. If you go in this particular direction, you will meet 0. Angle of asymptotes are the directions where the root locus branches are moving in this particular direction. You will meet 0, and the root locus diagram terminates at open loop 0. Okay, note down this. Okay. Now these are the angle of asymptotes. Is always symmetrical, and the total number of angle of asymptotes are the difference between poles and zeros. Now centroid sigma. What is centroid sigma? The centroid sigma is the intersection point of angle of asymptotes on the real axis. The centroid sigma is nothing but sum of the real parts, sum of real parts. Why real part? Because this intersection point is on the real axis. Sum of real parts of poles, open loop poles, minus sum of real parts of open loop zeros. Sum of real parts of open loop poles minus sum of real parts of open loop zeros by NP minus NZ. The real part we are considering because the intersection point is on the real axis, therefore there is no need to consider the imaginary part. What is the centroid for this particular problem? The centroid is sum of the real parts 0, minus 2, minus 4, minus sum of the real parts of 0, by np minus nz. Np minus nz is 3. Therefore, minus 6 by 3, which is equal to minus 2. Now the centroid sigma, which is nothing but minus 2. So all these particular angle of asymptote, you should be started at s equal minus 3, at sigma equal minus 3 is the centroid. Okay. So now this particular rules and regulations are sufficient such that you can at least draw the root locus diagram, or already options are available. You may easily say that, sir, this diagram is wrong, sir. This diagram is correct, sir. You can say with this particular rules. Okay. So with this particular rules, whatever we studied so far, based on that, we'll try to draw the root locus diagram for this particular problem. Okay. Now we'll start drawing the root locus diagram for the same problem. Now this is a plane. Identify the poles and zeros on a plane. Locate the poles and zeros on a plane and identify the root locus branches first. Now one pole is at origin, one pole is at minus 2, and one pole is at minus 4. This is the root locus branch. Now there is no root locus branch because even number. This entire real axis is a root locus branch. Now centroid sigma. What is the centroid sigma? Just now we are calculating for this particular problem. The centroid sigma, which is, this is the intersection point. Yes, this is the intersection point. Now this is the centroid sigma, which is the intersection point. Now from here, angle of asymptote. What is the first angle of asymptote? You are already calculated angle of asymptote. Now the first angle of asymptote is 60 degrees. This is first angle of asymptote. And second angle of asymptote is 180 degrees. Second angle of asymptote is 180 degrees. And third angle of asymptote, which is 300 degrees. I don't see all these things. Angle of asymptotes are always symmetrical. You just draw the symmetrical angle. That's it. Okay. This is another angle of asymptote, 300 degrees or minus 60 degrees. Angle of asymptotes are always symmetrical. Now see the root locus diagram. Very, very important. Okay. Concentrate. The root locus diagram starts with k equal to 0. The root locus diagram starts with k equal to 0. The root locus diagram starts with open loop pole. The root locus diagram starts with open loop pole. As k is changing, closed loop pole is moving. As k is changing, closed loop pole is moving. These two closed loop poles are meet at a particular point. That particular point is called as breakaway point. Now this is the point. Now the root locus branches leaves the real axis. With what angle the root locus branches leaves the real axis? Now with what angle the root locus branches leaves the real axis? Now the root locus branches leaves the real axis at an angle of plus or minus 180 degrees by n, which is equal to plus or minus 180 degrees by n is nothing but number of poles or number of zeros at this particular break point. At that particular break point, how many number of poles or how many number of zeros are existing? At this particular break point, there are total 2 poles, 180 degrees by 2, which is equal to plus or minus 90 degrees. What is the meaning of that? So you leave with plus or minus 90 degrees first. So we leave with plus or minus 90 degrees. Now this is plus 90 degrees and this is minus 90 degrees. Now k is changing, closed loop pole is moving, Now we don't know where should we go. Nobody is there. Now I am leaving. So after leaving, Now, is there any person is showing the direction? If you go in this particular direction, you will meet 0. There is angle of asymptote. Now, as k is changing, closed loop pole is moving in this direction because that direction is given by angle of asymptote. As k is changing, closed loop pole is moving. The root locus diagram terminates with k equal to infinity. The root locus diagram terminates with open loop 0. If you go infinity direction, now definitely we'll go get one open loop 0. Now see here, the root locus diagram starts with open loop pole and ends with open loop 0. Then this is called as one complete root locus branch. Understand not? Starts with open loop pole and ends with open loop 0. This is one complete root locus branch. Now this is one complete root locus branch first. Next, now that fellow is living with minus 90 degrees, and where it will go? Is there any person is showing the direction? As k is changing, closed loop pole is moving. Now this closed loop pole is moving in this particular direction because that direction is given by angle of asymptote. As k is changing, closed loop pole is moving, and it will meet 1, 0 in this particular direction because this is the direction which is approaches to infinity. Now the root locus diagram terminates with open loop 0, terminates with k equal to infinity. The root locus diagram starts with pole and ends with 0. Starts with pole and ends with 0. Start with pole and ends with 0. This is another complete root locus branches. Okay. Now started pole, ends at 0. Started pole, ends at 0. This is another complete root locus branch. Now see here. Now there is no root locus branch here, students. There is no root locus branch. Okay. There is no root locus branch. Therefore, now there is no movement. There is no root locus branch. There is no movement. Now see here. As now there is a root locus branch here. There is a movement of closed loop pole. Am I not? Now the root locus diagram starts with k equal to 0. The root locus diagram starts with open loop pole. As k is changing, closed loop pole is moving. As k is changing, closed loop pole is moving. And the root locus diagram terminates with, now see here, the root locus diagram, because this is one angle of asymptote, is showing the direction which are approaches to infinity. The root locus diagram terminates with k equal to infinity and terminates with open loop 0. Terminates with k equal to infinity, terminates with open loop 0. Starts at poles, ends at 0. This is another complete root locus branch. Complete root locus branch is a branch. This is the complete root locus branch. This is the second complete root locus branch, and this is the third complete root locus branch. What is a complete root locus branch? A complete root locus branch is a branch where it starts at poles and ends at 0. Now see, now what are the doubts here? Here we have some doubts. What is this breakaway point? What is the value of that breakaway point? That we will see. But what I am saying earlier, there exist two adjacently placed poles. Between them there is a root locus branch. Definitely there is a chance of existing one breakaway point. Now in the same situation is will be demanding here or not? Yes. And you see that the root locus diagram is always symmetrical about the real axis. The root locus diagram is always symmetrical with respect to the real axis. If it is any unsymmetricity with respect to real axis, that is not the correct option. Okay, you always choose the option with respect to real axis. Any root locus diagram, it should be always symmetrical, because with respect to real axis, the angle of asymptotes are symmetrical. Root locus diagram is always symmetrical. Understand or not? Now this is the root locus diagram for this particular problem. Right, I am drawing with the rules and regulation, but students, without that, then I will give one simple shortest way to you. You have to remember these 3 points, then there is no need of drawing the root locus diagram if the options are available. Now one point I want to say, if NP greater than NZ, if NP greater than NZ means practical transfer function. If NP greater than NZ, which means that practical transfer function. If NP greater than NZ, now the practical transfer function. If NP greater than NZ, now the practical transfer function is first point. Total number of complete root locus branches. The total number of complete root locus branches are NP. The total number of complete root locus branches are NP. Second point. And the second point is number of root locus branches. Number of root locus branches terminates at infinity is NP minus NZ. Number of root locus branches terminates at infinity is NP minus NZ. And the third point is number of root locus branches. Number of root locus branches terminates at 0 is NZ. Terminates at 0 is NZ. Now based on this is a practical transfer function or not? 3 poles, no zeros. Okay, 3 poles, no zeros. This is the practical transfer function. Now this is existing. If the practical transfer function, the total number of complete root locus branches are NP. What is NP? 1, 2, 3. Therefore NP equal to 3. Now number of root locus branches terminates at infinity. 3 minus 0 is 3. Number of root locus branches terminates at 0. There is no 0 here. NZ is 0. Now this is correct or not, you will verify. How many are the complete root locus branches by identifying from the transfer function? 3. 1, 2, 3. The total number of complete root locus branches are 3. 1, 2, 3. Is it matching or not? Is correct. Complete root locus branches starts at pole, ends at 0. Starts at pole, ends at 0. Starts at pole, ends at 0. Next, how many branches terminates at infinity? 3. Infinity, terminating at infinity. This is terminating at infinity. 1, 2, 3. So don't say this is 0. This is the 0 which is available at infinity. Now, but this is the 0 in the transfer function, but these zeros are not visible, but it is existing at infinity place. Okay. So that is why the total number of branches terminating at infinity is 1 branch is infinity side terminated, second branch, third branch. So this is also correct. Now, is there any branch terminating at zeros? Is there any branch terminating at zeros? Is there any 0 existing in the transfer function? There is no 0 in the transfer function. Therefore, there is no branch is terminating at that particular. Let us take for example here s plus 1. 1 0 is at minus 1. If 0 is existing, definitely at that particular 0, 1 branch is terminating. How many zeros? That many number of branches are terminating at that particular zeros. Okay. But in this problem, there is no 0. Therefore, no branch is terminating. What? Is there any advantages of all these 3 points? Yes. Because if the options are available, the given transfer function, 4 options in the 4 root locus diagrams in the 4 options, then first you check this, how many branches, total complete 3. But in option only 2 branches, wrong. In option only 1 branches, wrong. In option only 4 branches, wrong. In option there is 3 branches, there is a chance of correct. And how many branches terminating at infinity? 3. In option only 1 branch is terminating at infinity, wrong option. In option 2, 2 branches terminating, wrong. In option 3, 3 branches terminating, there may be a chance of correct. Okay, like that you can analyze and you can get the answer without drawing the root locus diagram, without remembering all the rules and regulations of the root locus diagram drawing. Understand or not? Now this is the way to draw the root locus diagram, n number of problems, same procedure. Okay. But we have some doubts in this particular problem. We will solve all the particular doubts. Okay, first you just note down this. Okay. Okay, this is the root locus diagram. Now, what is breakaway point? All these things we will see. Now, before that, then in this particular problem, see here, in this particular problem, these are very, very important points. Okay. Now, in this particular problem, now this is the open loop transfer function g of s, which is equal to k by s into s plus 2 into s plus 4. Same problem. Now I just add 1 0. I just add 1 0. Okay. Same problem. I just add 1 0. Then what happened? Now we'll see first. So first we will see what is NP. Total number of poles are 3. Total number of zeros are 1. NP minus NZ, which is equal to 3 minus 1, which is equal to 2. Right? So complete root locus branches are 3. Complete root locus branches are 3. One branch is how many branches terminating at infinity? At infinity there are 2 branches terminating. Now how many branches terminating at 0? 1 branch. Okay, 1 branch is terminating at 0. Okay, in a short method. Okay. Anyway, we will do the procedure as per procedure. So 1 pole is at origin, 1 0 is at minus 1, 1 pole is at minus 2, and 1 pole is at minus 4. Identify the root locus branches first. This is the root locus branch, no root locus branch, and there is a root locus branch here, and no root locus branch. Okay. Now, what is the angle of asymptote? Total how many angle of asymptote? 2. What is the first angle of asymptote? 180 degrees by NP minus NZ, 2, which is equal to 90 degrees. What is the second angle of asymptote? Don't do anything. The second angle of asymptote is the first angle of asymptote multiplied with the next odd number, which is equal to 270 degrees. Total number of complete root locus branches, NP equal to 3. Complete root locus branches. Now, NP minus NZ, which is equal to 3 minus 1, which is equal to terminates at infinity. And how many branches terminates at 0? NZ is only 1. So this is the first angle of asymptote theta degrees, and this is the second angle of asymptote, because totally 2 angle of asymptotes. Okay. Now, centroid sigma, the centroid sigma, which is nothing but sum of the real parts of poles 0, minus 2, minus 4, minus sum of the real parts of zeros -1 by NP minus NZ is 2, minus 6 plus 1 minus 5 by 2, which is equal to minus 2.5. Minus 6 plus 1 minus 5 by 2 minus 2.5 is the centroid sigma. Now centroid sigma is minus 2.5. This is centroid sigma is minus 2.5. From here, what is the first angle of asymptote? The first angle of asymptote is 90 degrees. And second angle of asymptote, don't see minus 90 degrees, you write directly. Because angle of asymptotes are always symmetrical. Symmetrical about the real axis. Therefore, now as root locus diagram starts with k equals 0, the root locus diagram starts with open loop pole. As k is changing, closed loop pole is moving, and the root locus diagram terminates with k equal to infinity. The root locus diagram terminates with open loop 0. Now, the root locus diagram starts with k equal to 0. The root locus diagram starts with k equal to 0. Now, the k equal 0. There exist two adjacently placed poles. Between them, there is a root locus branch. Definitely, there exists one break away point. As k is changing, closed loop pole is moving. As k is changing, closed loop pole is moving. And these two closed loop poles are meet at a particular point. That particular point is called as breakaway point. After breakaway, it will leave the real axis with an angle of plus or minus 180 degrees by n, which is nothing but plus or minus 180 degrees by n is number of poles are zeros are 2, therefore which is equal to plus or minus 90 degrees. Therefore, as k is changing, closed loop pole is moving. As k is changing, closed loop pole is moving. In which direction? Plus 90 degrees, leaving. And after that, where it will follow? It will follow the angle of asymptote. So, in this direction, if you meet, the root locus diagram terminates with k equal to infinity, terminates with open loop 0. Now, as the root locus branch is leaving, and it will go in this direction. As k is changing, closed loop pole is moving. Now the root locus diagram terminates with open loop 0. When k equal to infinity, the root locus branch terminates with k equal to infinity open loop 0. Starts at poles, ends at 0. Starts at poles, ends at 0. Now see, total how many complete root locus branches? This is 1. This is 2. And this is 3. Complete root locus branches are 3. How many branches terminates at infinity? 1, 2. How many? 2. How many branches terminates at 0? At 0, how many branches terminating? At 0, only one branch is terminating. At this particular 0, only one branch is terminating. Is matching or not? Now that is not the important point here. Now without finding the break point or all these things I am saying, and one important point, by adding a finite 0. By adding a finite 0, what happened? By adding a finite 0, now the branches on the right hand side, now this branches is on right hand side is completely shifted to, the branches on right hand side is completely shifted to left hand side, such that the system stability is improved or not. Here is in the danger zone, but by adding a 0, then the danger zone is completely will become safe zone. Okay. So the effect of adding a 0, which will improve the system stability, and the poles are completely moved towards the left hand side, system stability is improved. Okay, this is a very, very important point. Now this is the way to draw the root locus diagram without knowing a total rules and regulation. With a small rules and regulation, with a few rules and regulations, I will try to draw the root locus diagram which will give the correct answer. Okay, then we will see what is breakaway point, how to calculate, what is the procedure, and everything also we will see. Okay, now first you just take down this.